So, welcome guys to this webinar. This is a joint webinar by Cisco and SPIE. And today Joel is our presenter who will be speaking about the new developments in 61850 and what is going on currently in the working group 10. We have an option for Q&A. So the last 20 minutes is reserved for question and answers. If you have questions, please type them into the Q&A box and we will start answering them in the order that they come in. In case if we do not have time to answer your questions, we will respond to you by email. And all of you will also have access to the recording once the webinar is completed. Joel, it's all yours now.
All right. Thank you, Sindhu. I'm Joel Green from Cisco. I'll be sharing you a little bit with you today about what Working Group 10 has been up to, a little bit of history, a little bit of current events. As Sindhu mentioned, we'll be taking questions at the end, so please go ahead and put those in the Q&A slot as you think of things as we're going along, and we will come back to them when we get there. Go ahead and start some slides here. All right, and we have started a recording, by the way. Cindy mentioned that'll be available after. A little bit of standards update from 61850 from TC 57 Working Group 10. Quick word from our sponsors first. Cisco was founded in 1983 in Detroit, Michigan. We began with the mission of bringing new personal computers to bear to improve factory automation, mostly in the automotive industry, Ford, GM, Boeing. In the process of helping those robots take over the world, we fielded the first commercial implementation of manufacturing messaging system, MMS. In the 90s, EPRI, Electric Power Research Institute here in the US, started looking for a unified communication architecture for the utility industry, and we began working with them. Turned out our MMS technology fit the needs of this industry quite nicely, and we began work on that UCA that we shortly thereafter pivoted entirely into the electrical industry and have been there since the 90s. We've been involved, as I said, MMS is the underlying technology, communications technology that became UCA, then ICCP, and then 61850. So we've been involved in those standards as well as SIM since the beginning of all that. And that is our core business today. So moving on to what we're doing in Working Group 10. We have been a part of this group all along. We recently had a meeting in September hosted by Omicron in Austria. If you've not had the chance to visit that, I highly recommend it. It's a beautiful country and a very nice company environment. And we got the chance to stand on the roof in a cloudy morning against the Austrian mountains. As you can see here, we had a few folks turn up. CC 57 Working Group 10 is the largest working group in all of IEC. We've got somewhere close to 300 registered members at the moment. Typically, still haven't quite gotten back to pre-COVID numbers, but 70 or so typically we have in a meeting, and we go to some interesting places. This particular meeting, we just celebrated 30 years of 61850. 1995 is roughly when all this started. And so we had a good celebration, spent a day hearing from a lot of the folks that started all this. This crew you see before you here are, if you can make it out on the screen in the back, Omicron also hosted the 10th anniversary of 61850. And so they were very happy to have us back and provided a very, very nice event. The picture on the screen is from that 10th anniversary. And the folks on screen there are the ones that were present in the picture behind them. So we were able to line up who most of them were in the picture before. But over 20 years, things have changed a little bit. So we had a great day of celebrating that. Unusual to take a day off. We're generally working pretty hard. As I mentioned, we're the largest working group in IC and have a lot to do. We'll be talking about that today. Is what we're here for. So this is what a typical meeting looks like. And this was the Monday opening meeting in Austria at Omicron there in September. And we can tell this is the Monday plenary because Mr. Christoph Brunner is at the microphone leading our meeting. This was his last plenary meeting. Christoph has been the leader of 61850 essentially since the beginning. He's been the co-convener of Working Group 10. There was originally a 12 and 13 the standard was originally envisioned to be 3 separate working groups. Turned out to get things done, we all need to be together. So that collapsed into one of those, and Christoph has been our convener ever since. But as so many people seem to be doing lately, Christoph has decided he's reached a point in his life where he can't do 61850 all day, every day, like he has been for the last 30 years. And we're restructuring the leadership of the working group a little bit this year to accommodate that. Christoph wants to go pick grapes and do all sorts of interesting things. A team put together a proposal last year of how to handle his absence. As I said, he's been the core of this for 30 years. And it was concluded that it was going to take 4 or 5 people to replace him. So we have a new organization structure. Some of this is new across IEC. But Christoph is going to be around for a while. He will be a supporting role. And of course, we want to keep him happy with that as long as possible. His knowledge is vital, I would say, to the continuing the organization. But we have found a fantastic successor. Keith Gray has come into the 61850 world in the last few years, just before COVID, and has been a great asset and has stepped up to take the lead on this. So he and Christoph will be co-conveners for the foreseeable future, with Keith taking the bulk of the load there. We've also realized that that's just far too much work for any one person or any one company to commit to. And so we have added 3 technical coordinators. 61850 is based on 3 pillars. I actually recently heard that a lot of people still think of 61850 as a communication protocol. I'm about to put together a video through the UCA explaining a little more detail on that, because communications, is the least important. There are 3 pillars: communications, modeling, and engineering. We've instituted a technical coordinator for each of these 3 major parts of the standard. I am the communications portion, the modeling portion. The coordinator is Terry Dufar out of Germany. And for engineering, the Camille Bloch from France is the technical coordinator. So we help manage the process of producing the documents in those 3 branches. As I said, the communications is actually, in my opinion, the least important. That's where I've spent my life, and it's not unimportant, but there are a lot of other protocols that do that. It is really the modeling and most significantly the engineering that 61850 brings a real value. As I mentioned, I'll be talking about that in a UCA video shortly. So getting into what we came for today, talking about the work that we are doing in 61850, breaking it down into the 3 different areas. I'm going to go through, these are the works that are in progress right now. We have a lot more that are stable at the moment. This is the current work. We have, I believe I counted 30 some different projects in work right now. So it's a busy time. We've got a fair bit of people in the group, can always use more. Please reach out if you're interested in contributing to any of this work. These are the communication section documents. These are the ones under my responsibility. And then there's a number of different things going on here. TR 1-1 is the introduction and overview. It's a broad view of what's going on in the 61850 standard. It relates to a number of things in how the documents are processed. We've just, I believe it's released. I've been working on it recently, and it is in the IEC's hands to get released at the moment. The primary change in that is this describes the tissue process, and I'll talk about that a little bit later. This gives you an overview of how everything works. Next on the list, we have 8.3. 8.3 actually just got proposed and started at this meeting in Austria. And it is a very interesting bit of work. 61850 was designed with a number of core principles. Interoperability, vendor independence are a big part of that. But abstracting services is a big philosophical component of 61850. We want to be able to future-proof the technology. At the time 61850 was developed, we were had not consolidated on Ethernet yet. The OSI stack was still a big theoretical thing. We were using the OSI model. We were using E1T1, all kinds of different technologies that in the late 90s and early 2000s consolidated into Ethernet. So basically everything in the world's on Ethernet now, but there are variants within them. 61850 was designed to describe the services we need in an abstract way, and then concrete mappings, schisms, are the mapping to a particular technology. In this case, we've used 8.1 maps to MMS, which is what we've done for the last 30 years. There's been a couple of other attempts to do another mapping. There was a previous WebSockets one that didn't really take off, didn't get a lot of support. That was done through the web, through the WindPower folks. But we've got, and we had an 8.2, which maps XML encoding over XMPP over Google Chat. And that was put out for a very specific purpose, and there hasn't been a lot of adoption of that for a number of reasons. But we had this proposal to do a WebSocket JSON mapping. And this is coming out of the Netherlands. Tenant and Stetten, I believe, are the primary drivers of that. And the thing here is that this is for small DERs, so household solar inverters and the like, which need a small, very fixed profile. And so this is going to have a limited scope. It's not designed to meet the substation space by any means. It's designed to meet these small residential units. And there's a proof of concept project in the field. So they pushed forward. This is a real thing that's happening. And so they want to standardize the process and make it available to other vendors, other utilities. So I believe that that is going to go forward, whether others have not. So that's an exciting piece. Next up on the list is 9.3. 9.3 is a profile of PTP, of precise time protocol, of time synchronization for the utility industry, for 61850 in particular. So PTP offers a lot of options for a lot of different use cases across the world. It's used for everything. Financial services relies on it heavily, everything that needs time synchronization. It's much more precise than NTP and things that come with it, but because it has such a broad scope, we need some definition for what is required to use it for this industry, so that devices in this industry can be more interoperable. That's a dual logo standard with IEEE. PTP itself is an IEEE standard, so that profile has been worked on in the IEEE working group, but we're in the process of trying to get that published now. A lot of good work's gone into it. There is a bit of a debate on the scope of that document, but I believe we're close to resolving that and getting that published. So that's good. Part 10 is an interesting part of the world. Again, 61850 has a principle of abstracting requirements and mapping those to concrete use cases, concrete implementations. And we've done that with conformance testing as well. Part 10 of the standard defines at an abstract level the things that need to be tested in a 61850 device to make sure that it's conformant and can interoperate with other devices. As part of that history of UCA and IEC and all that I touched on briefly at the beginning, may get back into that a little bit more. It's a very interesting story, but the remnants that still matter today is that the UCA manages the test procedures for 61850. UCA International Users Group maintains the conformance test procedures and accredits the test labs that are capable of providing a certificate saying that these devices are conformant. Under the UCA, I chair the UCA Test Procedures Working Group. We maintain the concrete test procedures that the test houses use to go through what they have to do. But that comes from 61850-10, which specifies the abstract level test cases. So we just updated that. Edition 2.1 has just been published this year. Another set of interesting, the 80s are mappings, communications layers. 80-1 is currently in revision. It's been out for at least 10 years. Some updates were defined that were needed to do that. This is a mapping from 61870-5-101 and 104. 104 is those are primarily used for uplinks. They are similar to DNP, but an IEC standard. And so those are one of many protocols that we can use to get bits across the wire. They're fine protocols. They do a good job on what they do, but they don't give you any of the semantic data model of 61850. They don't give you any of the engineering process. You get information across the wire, you get a binary 32 or an analog 64, and you've got to somehow know what that means. You don't have any information coming across the wire as to that's the voltage on phase A, or that's the current, or any clue what that is. So you've got to transfer that knowledge with spreadsheets or in the back of a napkin or something from one end to the other to be able to connect what that data means. So what we can do is map those legacy devices into a 61850 system via gateway configuration, map that data wherever it comes from. We had to know what the device is giving us to begin with, but now that we know that, we can configure the gateway to map that back up, and we can add that 61850 semantic model, the real value here, into that in a gateway, and then provide all that information up to the larger system. So that's what this set of documents here does. 104, 101, DNP3. There's been a IEEE document out to do that, 1815-1. We're going to be revising that and plan to publish that as a dual logo. 8-2 was reserved for that use many, many years ago, and we're going to finally bring that in and do that in the style that we've done for some of these others. 80-5 is doing the same for Modbus. Modbus is an interesting protocol. It's out there. It's going to be there. It's no sign it's ever going to go away, mostly because it is cheap and easy. And so a lot of devices, particularly lower cost devices, can put that in their systems very easily. Well, since we can map that Modbus into a gateway and translate that information, add the semantic data model in a gateway and bring that up into 61850, we can really boost or reduce the barriers to introducing 61850 in legacy systems. And that's the real value here. We have constructed a format in SCL that we can identify how to get to the information out of a Modbus device and translate it into the 61850 data. Modbus devices have some interesting ways of arranging data, and the only way you can find that out is to read the owner's manual, figure it out. But we now have a way to encode that in SCL. So sometimes when you have a float in Modbus, you've got to go read register 16 and multiply it by the value in register 32 and add 17 and do all kinds of crazy things to map that data. We can now encode all of that in SCL and get that data up automatically through a gateway. So that is just released. I think that's a very valuable thing. There's a lot of folks out there with legacy devices that are slowing down 61850 adoption. So now we can bring those into the system. Okay, so a couple of other things. The 90 series generally gives us guidelines on what we're doing. 90-4 is currently in heavy revision. I'm looking for edition 3 of that. This is some network experts that are giving advice on what we need. And I said 61850 runs across Ethernet. We abstract that. We did that intentionally so that we don't have to be Ethernet experts. Make the assumption that the network is working well at the 61850 layer, but we have come to realize that that's not always a good assumption, and that there are things that need to be accounted for in the network engineering. So this is a technical report that describes the things that the user's IT staff needs to know to make a network that is functional and reliable, because when we're doing specialty protection class functions across Ethernet, it has to work. There are a lot of considerations that go into that. 9022 is network auto routing. So this is an interesting, fairly new topic that allows switches and routers to configure themselves based on what's going on in the network. So I don't think it'll be interesting to see where that one goes. 90-28 is communication supervision. This is fantastic work. It's a team that's been working on this for several years now. What we need to know is how to make sure that our communications are there. The base standard has reliability built in. For instance, Goose messaging has a retransmission schedule that optimizes making sure all the devices get the messages they need, and what to do when it doesn't. But when you have a large system, we need to be able to really know what's going on, if the subscribers are getting the messages they're supposed to. This goes into a lot of detail about, first of all, how to validate those messages. There's been some debate about all the fields in a Goose header and what's important to know that the stream you're looking for is the one you got. This goes through a lot of that and what needs to be checked and what doesn't, and how to identify. We have LGOS nodes that monitor those subscriptions. It goes through a lot of detail and has extended those classes to give more information about what's going on in the communication. So at a large system level, we can tell that everything's working. So that is the communication section. Fair bit of work going on there. Again, not a lot of ways we can get bits across the wire. But what 61850 really brings to the market is the concepts of data modeling and system engineering that give us robust processes. And so these are some of the works going on in here. 7.5 and 7.500 get lumped together. They're actually worked on the same task force. And their modeling guidelines, they're two different ones, because one's a general modeling description, and 7.500 is a specific substation guidelines. So again, we're trying to abstract things and separate out the uses of information. Those give you a lot of background on use cases, specifically how to breaker and a half. And we talked a lot about removable circuit breakers and how you model it and what it looks like when the rack's removed, the breaker's removed from the rack. Those sorts of things in the actual applications go in those documents. 90-3 gives us a lot of information about condition monitoring. There's been a lot of work going on in this area in recent years. Traditionally, utilities have maintained equipment based on rigid schedules. The manufacturer says my device needs to be has some maintenance cycle done every 3 years. Every 3 years on the clock, you roll a truck out there, you do what you got to do, regardless of whether it needed it or not. Utilities are starting to question that, realize that if we can actually figure out what shape the device is in, maybe 4 years is enough. Something's getting a little excess use, maybe we got to get out there in 2. So anytime we can optimize getting out there, maintaining that equipment just before it's actually needed, but no sooner, that's big money, dollars. So that's a lot of work been going into that one lately. 9014 fax, HVDC transmission. That's been going on a long time. There's a few, that's a sort of a niche there, but we're seeing more and more DC lines in the world. So this is building models and so forth. Most of our models in 61850 have assumed 3-phase voltages for all these years, and DC is different. So we've got some new models for that. 9018 goes into alarm handling. Throughout the system, we've got information comes back that operators need to be able to observe and take action on quickly, set up alarms. So we have a lot of guidelines for how to handle that, make sure the operators get the information they need correctly. 90-20 gives us a guideline for redundant IEDs. Redundant IEDs cause all sorts of troubles in our world, but they're often necessary. We need 2 devices to do the same function and switch over between each other if there's a problem. When you get into things like IP addresses that have to be unique across the system, convincing the upstream device to take information from either one of 2 has some unique problems. It's an interesting problem. And so there's a lot of work that's been going into describing how to do that correctly. There are some interesting things that have to be handled. A 9021 traveling wave based fault location. This is pretty cool stuff. A little over my head in some ways, but when you've got a 1,000-kilometer line going across great distances and you have a break or a short going on, you don't want to have to drive a truck off over that 1,000 miles to figure out where the problem is. Turns out we can bounce some waves up and down that line and predict fairly accurately where the problem is. So some neat work going on there. 9025 is past doing some model updates that came out of the 7500 work. I'll get into the different document styles in a few minutes and talk about why that's how we do that. 9029 is talking about physical resources. So we've been working for some time to model how the inputs and the outputs on the device actually look. 61850 abstracts all that. The model says, okay, I've got a voltage coming from somewhere, and the device hooks it up to an input, and that's great. There's a lot of use cases where we actually want to understand what the back panel of that device looks like. For test purposes now, we have test refs. We can actually swap out the inputs into a function from the software side. A lot of interesting, particularly testing applications of that. A lot of value there. That's a lot of work in going into how to map those physical inputs and outputs and other parts of the physical device itself. The next 2 are hot topics this year. Big stuff coming out. 90-32, we were talking about virtualization. Everybody's wanting to do that. Alex Apostolov has been dreaming of this for at least 30 years. We want to take our protection functions out of a relay and run them in a cloud server somewhere so that we can get all those advantages that Amazon and everyone else has had for years. We can seamlessly bridge over hardware faults and all that sort of thing. Well, when you're at protection level functions like we do in the power system with 62850, that's got to be a little more robust than Amazon does sometimes. Hopefully, we won't get ourselves in a position where Cloudflare can bring us down. There's a lot that has to be considered in that. We're working hard on that. Next up is modeling data centers. This is work that's just gotten started this year. It's an important piece. In most of the world, data centers are becoming a huge component of the power system. I was at a utility here in the U.S. last year, and the vice president gave a keynote address at the conference, and envisioned a time not too far off when they don't even bother to meter residential electricity. His view is that the demands of data centers are going to eclipse everything else they do, to the point that residential electricity is such an insignificant component, they might not even bother to charge for it. So that's a whole different world. They're growing, and their energy consumption eclipses everything else in the world. In many cases, they're building their own distribution networks. A lot of those now, they're buying medium and high level voltage, doing all the distribution centers on their side, which that's an obvious place for 6150. But because these loads are so huge, if they can expose what's going on in there and give some information out so the system can plan effectively, there's a lot of things we can do there to manage that. Some folks look at them as in the DER world. I don't share that view, but there's some similarities. There's some similarities to battery systems. Large-scale battery systems do something like that, but data centers are different beast in a lot of ways, and they're becoming such a huge part of the grid that we have got to address how to model those and be able to understand what's going on there. 9-34, we've got some new work coming online to transform regulation. So we need to be able to control those. That's some fairly new work, but we need to generate the models for how to account for those newer transformers. I believe some of the solid state stuff and all of that. All right, how are we doing on time? We're okay. And then the third component is the engineering process. And in my mind, this is the real value. We're going in order here. All of these have value, but engineering 61850 presents a rigorous standardized process for developing and describing electrical systems. And that process allows for efficient use of resources. It allows for utilities to hire folks that know what they're doing day one. Traditionally, at least in the US, utilities have built their own things sort of on their own, cobbled stuff together, had a nice system. They've been working on it 100 years. It works great. But you bring somebody in, they've got to learn how you do things. If you do things in a standardized method, everybody understands it. You can hire new folks off the street that have 61850 experience. They can come in and do that. From the employee side, it's time for me to move on. My skills are transferable. More value to me, more value to the employer. You get reproducible systems. We can build templates. We can reuse work. All of those values from proper modeling and rigorous processes. So these are some of the documents we've got, or the documents we've got under work in this pillar. Part 4 is system and project management. This document doesn't get nearly enough attention. A lot of good information in there about the broad scopes of how these things are managed. We are just initiating edition 3 of this document to update that. It's been a little while since that's seen some love. 6.1 is an interesting work that's going on right now. Part 6 has describes SCL, the system configuration language. It's an XML-based format for describing all of a 61850 system. It's like I said, it's the basis of the language of how to do the important part of 61850. We're updating that a bit. We've had a lot of work in UML over the years and in learning how to do modeling, the data modeling in UML. We brought a lot of that in. There's a lot of knowledge in that area, a lot of robustness in being able to check those models when we have them in a standardized format. And so that's the way we're going with all of that. Unfortunately, this STL schema was not originally developed in that kind of method. It was pretty early on. XML was a pretty new thing when SCL got started, and it was developed fairly manually. Well, we're now in the process of converting that to UML. So we'll generate the XSDs and all that from UML, which can then be validated and checked and all the wonderful things that come from having that machine processable. This 6.1, so first of all, we're changing from -6 to -6-1, and I'm going to talk about those topics in a moment here. But this document is going to essentially be the same content. We're just generating it from a UML model that didn't exist before. And the work here is to make sure we come out with the same place. 6.101 is the golden SCL. That's been in progress for quite a while. The idea there is that throughout the 61850 documents, there are snippets of SCL all over the place. None of them are coherent. Most of them are basically correct. Not all of them are. So the golden SCL is intended to be a coherent SCL file model that can be used in these examples throughout the standard. And because we have one true source on that, we can validate it thoroughly and spend our efforts, instead of one-off examples, spend our efforts making sure we've got one true good SCL file to refer to for all the examples. 6.2 HMI engineering, that project started and stopped a lot over the years. Not sure exactly where it's going, but the idea is to be able to generate an HMI directly from SCL, which is a great goal. It turns out people have different ideas of what they want their HMI to look like, so it has a lot of challenges, but we will see where that gets to. 6.3 OCL, again, with the machine processable and checking OCL's object constraint language. And that is a language that allows us to define rules for checking SCL. That is a very, very nice bit of work. 6.3 was actually just published in September, I believe. And we're in the process of building up a rule set for that. So the schema has to cover every possible combination of 61850 devices, from the device file the manufacturer gets all the way through to the complete SCD system. And so the syntax has to cover everything. You can't have rules for a particular case because it has to cover everything. Therefore, there are a lot of things in the schema that are optional, that aren't optional for particular use cases. With OCL, we can write rules so we can have machine processing and validation of those files. Great work there. It's a team now working on building out the rule set. If you have any interest in that, please reach out and I can connect you to the folks, because that's a good bit of work left to do. We've got the framework of how it's going to work. And it's starting the rules, but lots to build out there. 7.6 is basic application profiles. I'm actually going to talk about this one specifically in a few minutes. I'm going through that. 10.3 is functional testing. 61850 has done a lot of conformance testing and interoperability testing over the years, but has specifically stayed away from functional testing for the most part, performance testing. This document goes through a lot of information about how to functionally test specific devices, and that is in revision right now to go and improve that. Physical resources work is tying into that, so some neat stuff coming together. 80-7 system management. System management covers things like firmware updates, nameplate definition. How do you actually know? Most utilities have a considerable fleet of assets in the field, and just the job of keeping up with all those things, knowing where they are, what their state is, and when they need to be maintained and updated is a big job. So that's what system management's addressing. 90-19 is role-based access control. 61850 refers to the 62351 series of standards for cybersecurity. Lots of different pieces and parts to that. They define all of those, which was a good move for 61850 to get to leverage other experts in those fields rather than trying to do cybersecurity ourselves. It's worked out very well, but we're getting to the point now where we need role-based access. Protection engineers need to be able to do relay settings, but they don't need to change IP addresses. That sort of things. Different people can do different functions on the same device. Role-based access enforces who can do what. So we've got to take the 62351 work that authenticates the users that are in the device and map that into what those folks can do in the 61850 model. That's what 9019 does, is connect that authentication back into the model. 90-30 is a neat piece of work, and it got published this year. It is giving more information about the function modeling. LNs in the 61850 model are the communication blocks that show you the function in a device. It's got inputs and outputs. It abstracts that, but traditionally that's a black box. With 90-30, some work that's been gone in to help describe how that function is going to behave. That helps a lot with simulation, with testing, getting that information out into what that is going to do. So those are the documents that are currently under work in 61850 in Working Group 10. We are busy. If you'd like to help, please reach out and I will connect you to the right folks. So as I said, I'm going to come back to all the document types. You may have noticed in those last few screens on the right column, there was a lot of letters and numbers and things out there. The document number 61850 is an IEC part number, essentially. It defines a particular document. 61851-1. Well, there's actually a lot of different types of IEC documents. 4 in particular that 61850 deals with. At the highest level, we have the international standard. That's most of the documents that really firmly describe rules. These are the things we can really conformance test. Those are the standards that everyone needs to comply to. Most of our core documents are those. Then we have technical specifications. Technical specifications we tend to use as describing how to do a particular use case, and sometimes those make their way into international standards eventually. The next two are interesting. Technical reports. Technical reports we traditionally use to propose a new idea and get manufacturers to test it, and if it works, then it becomes an IS. Technical reports cannot, at this point, IEC says they cannot have any normative requirements. So they can't say you have to do this. That's been a little bit of a disagreement, or a little bit of a transition. We are now doing a lot more publicly available specifications. There's a lower bar to getting those out. Those can have some functional requirements. And so that's what a lot of our new documents are going to. So there's 4 different types of documents. In some cases, the document changes from one to another. When it does, it becomes edition 1 again. There's a lot of talk in 61850, edition 1, edition 2, edition 2.1. Well, those are all part of the IC part number process. And especially when these things can change and they're per document, there is no edition 2.1 of 61850. There's edition 2.1 of the core parts of the standard. A lot of those have been largely linked, but that's not really accurate to how we're using it. So what we're moving to, this example here, I talked about the 1.1 that I've just been working on. It went from, much like the part 6, it went from part 1 to part 1-1. So we had an edition 1 and edition 2. Well, now that we've changed the number, it's edition 1 again. So when I want to talk about edition 1 or edition 2 of a document, it's a little complicated to figure out what we're really talking about. So what we have decided to do in Working Group 10 a few years ago, when we started with the namespace definition concept, we added a namespace definition for each document we produce. And this is the general form. This is a, sorry about that, a technical report 90-25. And this string is defined in the beginning, just past the scope of the document. And it gives us the document number. The TR on the first tells us this, it's a technical report, tells us a transitional namespace. So this is a temporary work here. And then we have the year. 24A tells us when it is when it was published, and this is the first revision of it. So going forward, Working Group 10 intends to describe and discuss documents in terms of this edition, this namespace number, rather than the 2.1 or whatever that IC publishes each particular document, because this gives us a more precise identifier what we're working on. Another thing we're working on coming up next, next edition of Core, a couple big points that we're working on. I mentioned part 6-1 already. That is going to give us the UML underpinnings. But otherwise, that document is intended to come back and give us the same thing that the last version of Part 6 had, just with the UML backing in that. Part 7.4, which is the descriptions of our LNs, is going to be restructured quite a bit. It's gotten a little unwieldy, and we're going to break it up into a series of documents. Again, high level, low level, abstracting the 7.4 will contain the system level logical nodes. We have 2-digit numbers, 740, 43, 44, that give us information on models, in particular large scopes, primary equipment, instrument transformers, and that sort of thing. And then as we get into the 3-digit numbers, we've always had 7410 and 7420. Those are domain specific, so those get into models for substation automation up to DER. So we're just breaking those down so that catalog's a little bit easier to digest. One of the interesting parts in 61850 tissue process, 61850 started at a time when IC was producing paper documents, and the maintenance process was tuned to that. And that was certainly not fast enough to correct errata in the standards at the speed we needed. So we created an entirely new process. It is now being used by other working groups, and we've had a few updates this year. We've polished this process over 20 years. We're now batching tissues so that the market's a little more stable. With that, we produce an INF document, informative document, when we release a batch so the market knows what's happened. And we recently went to producing core agenda for each part that's affected when we release that. The core agenda stays in the web store. If you own the standard, you have access to that, whereas the INF document has a limited lifespan. And I am going to have to accelerate here just a little bit. The other thing I said I was going to come back to, basic application profile 7.6. This is 61850 covers basically any use in the electrical space. Makes it very hard for users to figure out what they need sometimes because the standard covers every case. The BAP allows for the user to specify their application and their requirements, really. That is an important piece to be able to get back in there. It has a machine processable format that allows users to compare their requirements to products on the market. So that's a neat piece of work. And that's going to drive into our IOP this year. The UCA, as I mentioned, was the precursor to 61850, and the UCA users group still exists under that name, even though the standard became IEC 61850. We just this year had our first 61850 user group meeting. Fantastic time. This, unlike other conferences, is focused on providing a venue for users to be able to talk to each other and exchange their stories. So I'd highly encourage you to look into that. We are in the process of planning an event in Europe next year. So we will get some information about that out shortly. The other big part of UCA for 61850 is the IOPS. We've been doing every 2 years for, I know since 2012, somewhere in that range. And every year we do a lot to expand the standard, push the boundaries, figure out where things break. And we are doing a lot more this year to focus that on those BAPs because it's about the user interface that we need to work out there. And I think that we are out of time for today. We've got a little less time than I thought. So let's go for our questions. Right. Got a few things here. Got a question. It says 8090 series are widely considered as nice theoretical developments, but no manufacturer has implemented any of that stuff. Good point. That's an excellent point. I would disagree on the 80 series completely. The 80 series is functional. Those generally have seen use. 90 series is some of that is theoretical. As I mentioned, those technical reports are sometimes putting concepts out there so that the market can start to experiment with them. They are put in use in many cases, but then we find out whether they work or not, and a lot of times improve them and eventually roll them into the core standards. Primary example I could give you on that is 90-5, which is routable goose and sample values. Goose and sample values in the core standard was layer 2 multicast Ethernet, so not traversing routers. Great in the substation, super fast, easy, life is good. But we identified some use cases where you need to be able to exchange goose outside of the substation, between substations. And 90-5 described how to wrap those goose in a UDP header. They can do that. It absolutely was implemented. In fact, there are still, with edition 2.1, that got wrapped into 8.1 and 9.2. But you'll still see products on the market advertising 90-5 conformancy. So yeah, in some cases, there are some interesting ideas. In a lot of cases, they are guidance. Like I said, 90-4 gives you guidance on how your network needs to be implemented. So some of them aren't particularly implementable, but yeah, they do get used in the market in general. Is there a task force on specifying cybersecurity controls in SCL? Yes. Yep. There's current work. Cybersecurity comes along in Working Group 15, 62.351. But yes, there's a lot of work going on. It's not a simple task, but there's work going on to encrypt SCL, to manage how that's going on. And defining a white access list of clients for a controllable object. Yep. So that comes back into the role-based access control I mentioned. 90-19, 61850-9019 maps the authentication coming out of the 62351 series into specific 61850 objects. Controls are an excellent example of that. So we can control who does have access to particular functions in the device. All right, well, we appreciate you spending a little time with us today. Looks like we're up against the clock here, but if you have any further questions or interest in any of these subjects, feel free to drop me an email. Happy to chat about any of this, and hopefully we'll see you in another webinar soon. Thank you. Have a good day.